Hey, just a quick little lesson for you guys today on power. This is entitled Lesson 6.3c. And now power is really just the rate of doing work or the rate of consuming energy or using energy. Now, just to kind of give you an idea, if I was to be lifting a 50 kilogram object and I'm raising it up 3 meters. Now, if I do this in 1 second, or if I did this over 1 year, which one is more powerful, right? Well, they're both doing the same amount of work, but doing it over a time of 1 second as opposed to 1 year makes this more powerful because it's doing it using that work at a faster rate, completing that work at a faster rate. Okay, so simple formula, power is equal to work divided by time, and the units we use for power is the watts, which is 1 joule per second, joule being work, and seconds being the standard unit for time. So let's take a look at example number 1. Find the power used by Amelia if she applies a 300 Newton south force and displaces the object 5 meters south in 20 seconds. Now, if there's 100 newtons of friction opposing her initial force, well, if we take a look at the object now, we're applying 300 newtons this way, we've got 100 newtons this way, but in order to find the amount of work, we're going to use, again, the applied force there. And so power being equal to work over time, that work is just force times distance divided by time. So we're using the 300 newtons of force multiplied by 5 meters. Now they're both going in the south direction, so that's all good. Divide that by 20 seconds. The amount of power output is 75 watts. Let's take a look at this next example. Student runs up a 60 kilogram student runs up at a constant 4 meter ramp, angle of 30 degrees to the horizontal in 4.5 seconds. What's the power output? Well, in this case here, it's a 4 meter ramp at 30 degrees. What height are we actually reaching? Well, that's going to be 4 meters sine 30 degrees. That's also equal to 2 meters. Okay? And so we're going up 2 meters. We're lifting this person up 2 meters in a time of 4.5 seconds. Work is again equal to force times distance over time. Sorry. That would be the power. So let me erase that. That's the power is equal to force times distance over time. We're looking for the power here. The force is going to be equal to 60 kilograms multiplied by 9.81, bringing this person up against gravity, right? And over a distance of 2 meters divided by a time of 4.5 seconds. And again, we're using this because the force that we're using and the distance need to be going in the same direction for work to be happening. And so this winds up being 262 watts of power. Our third example, we're not given a distance. What we're given is an initial velocity, a final velocity, and a time. We've got mass of the vehicle, which is helpful, and so we're going to need to find both the acceleration and distance. Like if you think about this in terms of force times distance over time, or power is equal to work being mad over time, We don't have time, we don't have distance, but we've got initial and final velocities. So with the acceleration being equal to change in velocity over time, and we've got a change in velocity, we've got time, so we should be able to find that acceleration. That change in velocity going from rest to 15 meters per second is a 15 meter per second change over 4 seconds, which means that this is going to be a 3.75 meters per second squared acceleration. We also need to find the distance. Distance is equal to VF plus VI over 2 multiplied by t, which means 15 divided by 2 multiplied by 4 seconds, where the distance or displacement is going to be 30 meters. So coming back to here, we now have the mass of that 1,000 kilograms, an acceleration of 3.75, distance of 30 meters, and all happening over 4.5 seconds. Power output here is 2.8 times 10 to the 4 watts. One last little example here. We've been given a mass and we've been given a velocity. Now, up until this point, force times distance over time. Now, look at this. Distance over time. What is that? Well, that just happens to be the velocity. So really, force times velocity is going to also equal power. So we've got a velocity, we've got a mass, and we know that it's lifting this crate, which means it's going against gravity. And it's happening at a constant rate, which means we know that force applied is going to be equal and opposite to gravity. So we can take that 400 kilograms multiplied by 9.81 meters per second squared times 0.5 meters per second. And so what you wind up with is 1.96 times 10 to the 3 watts. Hopefully that's helpful, and thanks for watching.